This question is from GATE 2012 Mechanical Engineering paper, question number 27. Details pertaining to an orthogonal metal cutting process are given below. The chip thickness ratio 0.4, undeformed thickness 0.6 millimeters, rake angle is 10 degree, cutting speed 2.5 meter per second, mean thickness of primary shear zone 25 microns. Let's give them symbols. So we have chip thickness ratio as 0.4, which is denoted by small r. Undeformed thickness, let that be T. Rake angle is alpha. These are all the standard denotions. Cutting speed is denoted by VC, and mean thickness of primary shear zone that is to be actually cut is TM, mean thickness. We have to calculate shear strain in per second. Shear strain given as epsilon dot, that is derivative of epsilon with respect to time, is nothing but the shear strain rate. Let's see how it will be found out. So we have written the given information here. As we need to find the shear strain rate epsilon dot, it is given as shear velocity Vs upon the mean thickness of shear zone, that is Tm. Now Tm is known. If we manage to find Vs, we'll be able to find out epsilon dot. Vs is given as, so there is a proportion between the shear velocity and the cutting velocity, that is Vs by cos alpha is equal to Vc by cos phi minus alpha, where phi is the shear angle. Now we know Vc here, we know alpha here, but we don't know the shear angle. So if we manage to find shear angle, then we'll be ultimately able to find out the shear strain rate. So phi here can be calculated using tan phi is equal to r cos alpha upon 1 minus r sin alpha. This formula is a standard formula used to calculate the shear angle for metal cutting process. Now let's start by using the shear angle formula. Go to finding out Vs and then finally finding out the shear strain rate. Number one, for tan phi, we have it is equal to 0.4 cos 10 divided by 1 minus 0.4 into sin 10. This, when substituted in the digital calculator, we get tan phi is 0.4233, and therefore phi will be equal to tan inverse of this value, which comes out to be 22.9 degree. Now we know phi, we can then find out Vs. Vs is equal to Vc, which is 2.5 meter per second, 2.5 into cos 10 divided by cos 22.9 minus 10, which is cos 12.9. This is calculated to be 2.525 meter per second. Now we know Vs, we can find out the shear strain rate. Our final answer for shear strain rate is 2.525 divided by mean thickness of the shear zone Tm is given as 25 micrometers. Microns means micrometers. It's the thickness, so definitely it's a distance value. We have 25 micrometers is nothing but 25 into 10 to the power minus 6 meters. This value comes out to be 1.01 into 10 to the power 5, as here the units were meter per second per meter. So we have the unit of shear strain rate as per second. Remember, this is shear strain rate and not shear strain. Shear strain is given as gamma, which is calculated with a different formula. This is shear strain rate. Let's go back and mark the correct option. So we have in the options, option C gives us the correct shear strain rate in per second, which is 1.0104 into 10 to the power 5. To learn more about determination of stress strain and strain rate in metal cutting process, especially orthogonal metal cutting process, you can refer to the NPTEL video Determination of Stress, Strain and Strain Rate from the course Mechanics of Machining. This course is by Professor Uday S. Dikshit. He is from Department of Mechanical Engineering of IIT Guwahati. I hope this solution will help you clear your doubt. Thank you.